Let's talk about correlation analysis this week. Here's today's goal. I want you to understand what is correlation. And I want you to understand how to do correlation analysis. Let's review fundamental process for data utilization. This is a process you have to take in order to utilize data or data analysis. First, we defined the objective of using data. Then we identify the right data to use. And we evaluate the current situation or current status by comparing two datasets. And we learned how to compare the data. We talked about multi-angle approach. And now we shift our focus to cause identification. We have never seen what was the cause of the result. We focused only on the results so far, but now we are digging more about the causes of the result. In order to identify the cause or causes of the result, we will use the concept of correlation. What is a correlation? Before talking about the correlation itself, let's change our focus of the data view from one single axis or one single data set to multi-axis. That means two or three sets of data, so that we can get more insights, in this case the cause identification from the data. Let's look at the graph on the left-hand side. This is very common graph to show the sales results by outlet. Let's say this graph shows a monthly average of the sales result. For example, outlet A average sales result was 360, and for B it was 580. As you can see, this is one single axis which shows sales result only on the vertical axis. This is called one-axis view. With this approach, with one axis, you can find only result, in this case, sales result. But you never know what makes this result. In other words, what are causes of this result? But without knowing the causes, you never know how to improve it or how to resolve it. In the business settings, what you really need is not just the result, but you need to know what caused the result. So cause identification is very critical. Then let's look at the graph on the right-hand side. As you can see, you have two axes. One is sales result. This is the same as the one we saw already. And in the horizontal axis, you can see the number of visitors. And we will focus on the relationship of the sales result and number of visitors. Can you guess which is the result and which is a cause? It is obvious. Sales result is the result or outcome. The number of visitors is a cause of the sales result. So, in this case, you put the result or output or outcome in the horizontal axis. No, the vertical axis. And then you put cause, reason, or input parameters in the horizontal axis, and then you will find the relationship visually on the scatter diagram. What can you see from this graph? You can find linear straight line relationship between sales result and number of visitors only for outlet B, A, and C. This makes sense because more visitors you have, the higher sales result you have. This is very simple linear relationship. But if you look at this chart, this graph, you will notice the outlet D is far from this line. If you assume these four outlets has the same brand and has the same product line, what is the issue in these four outlets? I don't see any issue for outlet A, B, and C because they are almost on the line, a straight line between number of visitors and the sales result. On the other hand, outlet D is far from this normal line, so to speak. So you can find the relationship between two axes, sales result and number of visitors. In this case, maybe it is a straight line. And you can also find outlet A, B, and C are on the line, which does not show any issues. But you can see some issues about outlet D because it is far from the normal line. So you can first, you can find the relationship between the two parameters, sales result and number of visitors. Second, if you have some outlier, in this case, that's outlet D, you can identify the issue or outliers from the normal relationship. Okay, this is the difference between one single axis on the left-hand side, which shows only result, and two axes to show the relationship between the two. By using the one on the left-hand side, two axes, then you can identify the relationship between the two parameters, two index. That is something new in this class, and I want you to shift your focus from one single axis to multi-axis, in this case, two axes. So once you make your output from data, for example, some graph or something, you can ask yourself this question. Have you identified the cause or reasons, not only the result? This is a very important key question. Don't stop using the data or graph by showing or visualizing only the result. This is not a goal. The goal is once you visualize the result, then think about the causes of the result. That is the question I want you to repeat in any practical exercises or your job or your assignment or your presentation. Whenever you use data or graph, please ask this question for yourself and make sure you identify or you address the cause or reasons. How can you identify the cause or reasons with data? For this objective, I'd like to introduce the new concept or new technique, new analysis, which is called correlation analysis. Here is a definition of correlation analysis. Correlation is a technique for investigating the relationship between two quantitative continuous variables, for example, age and blood pressure. So, correlation is to identify or find the strengths of the relationship of the two things. For example, age and blood pressure, they should have some relationship, but how strong? Or is there really the strong relationship between the two? In order to investigate this relationship and strengths of the relationship, you can apply correlation analysis. And in the correlation analysis, we will use the parameter called correlation coefficient. Here is the definition. Correlation coefficient is a measure of the strengths of the association or relationship between the two variables. The value ranges from -1 to +1. Correlation coefficient is the parameter we will use in the correlation analysis, but its range is only from -1 to +1. So this index coefficient shows somewhere between -1 and 1. And how do you know the strengths of a correlation? You can see that the chart below. If this coefficient, the value is around 0, that means these two data sets has no correlation or weak correlation. If this coefficient is 1 or close to 1, that indicates these two data sets have strong positive correlation. If this is 1, you can say this is a perfect positive correlation. When you look at the opposite side, -1 or close to -1, that means these two data sets has strong negative correlation. And what does it mean by positive correlation? That means, let's take two different data sets. If one data goes up, the other one also goes up simultaneously, and this number goes down, this number also goes down. That is shows the correlation, positive correlation. How about the negative correlation? That's totally opposite. If this goes up, this goes down. If this goes down, this goes up. So the direction is not the same or opposite. That's negative correlation. If this parameter or coefficient is small enough or close to 0, they really don't have any correlation. They are changing independently. In such case, you can say they don't have any correlation. From statistics point of view or mathematical viewpoints, you can also say if these two data sets has a correlation, they have linear relation. What does it mean by linear? Linear means if this goes up, double. If this is number double, this number also double. If this is triple, and this is triple as well. So this is a linear. Linear means if you draw a graph, linear means straight line. So if you find with graph, if you find straight line or close to straight line relationship between this axis and this axis, that means these two data sets have correlation. If this is positive correlation, it is a straight line like this. And if this is negative correlation, it's the opposite slope, but still it is straight line. Let's look at it with some examples. Here are some examples. The first one, left-hand side, the upper one. R stands for the coefficient of the correlation. In this case, if you look at variable 1 and 2, you can see any relationship on the chart in the graph. In this case, if you take the coefficient, it is just 0.22. This is small enough. So you can say these two variables or data sets don't have correlation. How about the right-hand side, the one on the right-hand side? You can see the almost straight line. If the variable 1 increase, variable 2 also increase. So that's positive correlation. And it shapes like a straight line. If you take coefficient, that indicates 0.91 in this case, which means these two variables or dataset have strong positive correlation. And the last one is the opposite. If variable 1 increase, variable 2 decrease. That's the opposite direction. So if you take the coefficient in this case, that indicates minus 0.83. That is close to minus 1, which means these two variables or data sets have strong negative correlation. Now you understand what correlation means and how the correlation coefficient shows the result. Now let's look at the technique how to calculate coefficient with Excel function. The Microsoft Excel has a function called correlation. As you can see on the top, that is the abbreviation of correlation, C-O-R-R-E-L. After this function, you can choose two data sets and you can put the comma between the two. I will show you the demonstration of how to do it with Excel late after this video. Here is an exercise 1. How would you analyze the effectiveness of the expenditures? That means you have promotion expenses and also incentive for visitors expenses. The goal of the two promotion, one is the first on the promotion and the incentive, is invite more visitors. So if you look at the column on the right hand side, that is the result of the two activities, promotion and incentive. So you can say two activities and one result, which is number of visitors. And you have to investigate and justify all those two activities are positive, effective to invite more visitors. In this case, promotion and incentive are inputs or causes of the result of number of visitors. Two input and one result or output. So this is the numbers to show two activities and one result. How are you going to show promotion expenses correlate with number of visitors? This is the first step. Second step is you can make sure incentive correlates with number of visitors. By using correlation function of Excel, please make sure which activity or both activities correlate the number of visitors as a result. This is the first exercise. Here is the second exercise. As you can see, you have the breakdown by age group of the number of visitors. In the first column, you can see the marketing expense by week, starting from $9.6 thousand. You want to make sure this marketing expense correlate which age number. In other words, this marketing activity invites the visitors from which age group. So in this case, you can find correlation between marketing expense and number of visitors by age group. So you can take a correlation coefficient between marketing expense and number of visitors in 20s. And next, marketing expense and 30s, and marketing expense and 40s. You can repeat this exercise and you can see with which age group marketing expense correlates. If you can find strong coefficient, correlation with some age group, that means this marketing expense is effective for the age group. You can also apply this technique or concept when you make survey questions. Now let's say we have 4 questions. The first one, how much would you like to take the statistics class? 1 is the lowest, and 5 shows the highest. And next, how much do you like the professor? And how much is the program effective? And finally, how much is the workload of the assignment? The 1 shows light, very light. 5 shows very heavy. And now we got the answers from a certain student group. Once you take a correlation between the first question, how much would you like to take the statistics class? This is the degree of the preference of this class. And if you take this result, correlation of this result with other 3 questions, you can see the correlation between the questions. Now you can find the result. What can you say from this result? What is your conclusion based on this result? You can say the second question, how much do you like the professor? It doesn't have any high correlation with the first question. That means whether you like the professor or not does not affect the result of the first question. So it doesn't matter how much you like the professor in order to decide to take this class, statistics class or not. How about the next one? How much is a program effective? So this is a question about the effectiveness of the program or class. It has high positive correlation with the first question. That means the student's decision about taking the statistics class or not is coming from their perception of the effectiveness of the program. simply because they have high correlation. How about the last one? How much is the workload of the assignments? It also has high but negative correlation with the first question. That means if the student think the workload is very light of this class, yes, they may take this statistics class. So the workload of the assignment has the high impact of their decision whether to take this class or not. So please notice the direction of the high and low, and the correlation, positive or negative, is not the same between the last two questions. The third question has a high positive correlation, while the last one has a negative correlation, simply because the answer 1 through 5, the direction is not the same. So this is one example of how you can apply the correlation concept and technique even for the survey question design or analysis of the result. Now this is the assignment, and I want you to find an example of two correlated variables in your daily life or in the social news or whatever, and show the correlation analysis result. I want you to find very interesting and very insightful examples of the correlation. And I want you to pick up some data from the website or newspaper or the magazines, whatever. Or you can ask some questionnaire to your friends. And then try to find the correlation between the two data sets. And let us see the correlation if coefficient and scatter diagram as well. I just need a simple result, and hope you can find a very insightful result and a very interesting examples. Good luck.